Good evening, students. I'm going to go through a little bit of this homework. Hopefully it will help you to get the steps down and notice the parts of these graphs and to be able to find the axis of symmetry and plot points, etc. Graphing these quadratics. Number one, write the equation for the axis of symmetry. The axis of symmetry is this line right here which cuts the parabola into two halves. And it goes through x equals 1. That's the equation of the line that is called the axis of symmetry, x equals 1. What is the y-coordinate of the vertex? Well, the vertex here is at 1, -4, -4. The vertex then is 1, -4. Write the x-intercepts as ordered pairs. So here's an x-intercept here, and here's an x-intercept here. It's where the graph crosses the x-axis. It's where it intercepts it. The first point here is at -1, and the y value is 0. And here the x value is 3, and the y value is 0. Stating the domain and range here, remember x such that x is an element of all the reals. And the range is y such that y is greater than or equal to -4. Is this a maximum or a minimum? It's a minimum. What is its value? -4. I did number 10 in class with you. I'll go ahead and do number 9. You have the answers, but I'll show you how to do it. The axis of symmetry is equal to the opposite of b over 2a. So it's equal to the opposite of 4 over 2 times -1. So that equals -4 over -2, which is 2. X equals 2. The vertex can be found on the axis of symmetry of x equals 2, can be found on this axis. So we're going to put 2 into our function. And when we put 2 in, the value we get out for y will tell us where the vertex is on the axis of symmetry. So the opposite of, notice I almost always use parentheses, the opposite of 2 squared plus 4 times 2 minus 3. And we get -4 plus 8 minus 3, and that's equal to 1. So when we put 2 into the function for x, we'll get out 1 for y, and that's our vertex. For number 3, the y-intercept is always our c when we're in standard form, so it's -3. Or you could let x equal 0, and then see what happens to the function. -0 squared plus 4 times 0 minus 3. That's 0 plus 0 minus 3, and we get -3. Either way works. Now to find other points, first let's put our axis of symmetry in at x equals 2. And the vertex is at 2, 1, 2, 1. Right on that axis of symmetry. It's always on the axis of symmetry. And the y-intercept is -3, so that's down here. Down here at -3. The vertex and the axis of symmetry, and 3 can be reflected across the axis of symmetry over 2, over 2. So now we have 3 points. We'll need 5 for our parabola. So I have a value here. I could try x equals 1. I don't have a y value yet for that x value. Or I could try 3. I don't have a y value yet for that x value. And if I plug in 1, I'll get some value out for y. So in my function, I'll put in x equals 1. So the function is, just to rewrite it down here, so you can't really see it very well. The function is negative x squared plus 4x minus 3. So I'm going to put x equals 1 into there. The opposite of 1 squared plus 4 times 1 minus 3. It's the opposite of 1. 1 squared is 1, so it's the opposite of that. Plus 4 minus 3. That's 3 minus 3 is 0. So if I put 1 into the function, I get 0. And I'll mirror that point across the axis of symmetry. And now I can draw my curve for my parabola. The domain is x, such that x is the element of all the reals. And the range is y, such that y is less than or equal to 1. On the other side, I'm going to just do one of these. I'll do number 1 and follow the steps carefully and do them in this order. If at all possible, this is the best way I have found when we're dealing with trying to use the axis of symmetry and the vertex. We should do those first two. So remember, the axis of symmetry, step 1, x is equal to the opposite of b over 2a. So to find the axis of symmetry, I will take the opposite of b, which is the opposite of negative 4, all over 2 times 1. So that's equal to 4 over 2, which is equal to 2. I can sketch that axis of symmetry of x equals to 2 right there. X equals 2. Now to find the vertex, I take x equals 2 and put it into the function to get a y value. Somewhere on this axis of symmetry is the vertex. So if I put 2 into the function, it will tell me where. 2 squared minus 4 times 2 plus 5 is equal to 4 minus 8 plus 5 is equal to negative 4 plus 5, which is 1. So my vertex is now at, running out of room here, 2, 1. 2, 1. On this axis of symmetry, there's a vertex. Now this parabola is going to open upwards because a is positive, a is greater than 0. So this parabola is going to open up. And so my points should be somewhere up here. The y-intercept, remember, is our c. So the y-intercept equals 5. 1, 2, 3, 4, 5. And I can reflect that across the axis of symmetry, and there's the other point. 1, 2, 3 points. Now I'll need to find 2 more points. In other words, I'll find 1 and then reflect it. I can use this value for x here in the function, and that will give me some y value up here. Or I can use 3, and that should give me some value here. I'm not going to use negative 1 because it's going to probably give me some very big value. And if I use 5, same thing. So I'm going to use something in between these 2 points. I'll use 1. So step 4, I put 1 into the function. 1 squared minus 4 times 1 plus 5 is equal to 1 minus 4 is negative 3 plus 5 is 2. So my point will be 1, 2. I put 1 in, I chose 1 to be my value, and I got a y out of 2. So 1 is my x value, and 2 is my y value. And it's right where it should be along the line of what this curve is going to be. And I'll reflect that across the axis of symmetry and draw this line in, this curve in. And there is my parabola. I think maybe I'll do one more, just to be sure that you're getting the right idea here. And you don't have the answers for 13 through 15, so I'll do number 14.